Hello everyone. Today we will discuss about the wireless transmission, the antennas or antennae, and different types of antennas. So let's get started. First we will define wireless transmission. So what is a wireless transmission? We can simply define wireless transmission is the data exchange without any physical conductors or without installing any wires. So it is a network. It is like a network of two devices or more than two devices in which we transfer the data from one point to another point without installing the wires or any other physical conductors. Let's say we have 2 points, one over here and one over here. So we want to transfer the data from this point, let's say it's point A and it's point B. So we want to transfer the data from point A to point B without wires and other physical conductors. So the transmission or the transportation of the data from point A to point B is called wireless transmission without putting any physical conductors and wires. This wireless transmission takes place via electromagnetic waves. So you know that the wireless transmission from point A to point B will take, let's say this is point A and this is point B. So this transmission or the data transportation from point A to point B will be in the form of electromagnetic waves. It means that this wireless transmission will include electromagnetic waves. We have different types of electromagnetic bands from the electromagnetic spectrum which we can use to transfer the data. Now, from point A to point B to transfer the data, we will need some electronic devices. There must be some electronic devices that is able to transfer the electrical pulses or electrical data or electrical signals into something that it can travel in the air and then it can be received by something or some electronic devices that can sense that data or signals, and then they should be able to convert that data into electrical signals or electrical data. So for this we will use the wireless antennas, or we can say the wireless antennae as a plural. So there are different modes. So transducers are electronic devices which convert the data from, or which convert the electrical signals from one form to another. So we need the electrical signals to be converted, and that these electrical signals should be converted so that it can travel in the air without the need of any medium. And also on the other side, there should be an electrical device or electronic device that is capable of converting that or those electromagnetic waves to convert them into some electrical signals or electrical data. Let's suppose we have two devices, like we have one device over here and the other device is over here. Let's say this is device A and this is device B. Now these devices, in this case, in case of A, this device will convert the electrical signals or the electrical data into electromagnetic waves so that they can travel from point A to point B without the need of any physical conductors or physical wires. Okay, we will discuss about antennas in detail in the coming slides, and before that we will discuss about the different modes according to our needs that we need in our daily life. So wireless transmission can occur in different modes. Now, What is transmission modes? Transmission modes are different situations, or they are different procedures via which we can send the data from one place to another. So we have three transmission modes. One is the ground wave propagation, the second one is the sky wave propagation, and the third one is space wave propagation. So what is ground wave propagation? In ground wave propagation, we use frequency from 3 kilohertz to 3 megahertz. These are the waves which are able to follow the curvature of the earth, or different ups and downs of the earth. So they can travel easily. But one disadvantage is that it will not go so long. Let's say we have to transfer the data from one point to another. Let's say this is an earth curvature, and here we have one device and the second device. So if you want to transfer the data from this device to this, the second one, the wave will follow the path without any obstruction. So it will have no issue to go from one point to another point. So ground wave propagation use the frequency range from 3 kilohertz to 3 megahertz. They can travel along the Earth's surface, and the reason they use the low frequency is because, let's say if you use high frequency for the ground wave propagation, let's say this is our ground, right? And we use frequency from like 3 kilohertz to 3 megahertz. Okay, so let's say this is our ground, and we are using frequency from 3 kilohertz to 3 megahertz. So the frequency will move along the Earth's surface. Let's say this is the Earth's surface. As the frequency moves along the Earth's surface, it will induce another wave in the Earth's surface, like this. If we can see this part, in this part the wave there is possibility that in this region we will have the energy leakage, and it will cause the signal to attenuate. So that's why we are using low frequency. For instance, let's say if we use high frequency, this is our ground, and if we use high frequency, so low frequency will induce another frequency or another wave in the ground, which will be like this. So in this case we have possibility to get our data or get our signal to leak it more energy. So at these points the possibility of leakage of energy is maximum. That's why we are using the low frequency for ground propagation. Okay, so the maximum distance it can cover, like from 100 kilometers to 1000 kilometers. And we are using the AM radio during the daytime, because during the daytime it can travel very reliably. Now we have another kind of transmission mode. This is the sky wave propagation. The sky wave propagation occurs above the troposphere. The troposphere is like 15 kilometers and up to the ionosphere. Now we have another transmission mode, that is sky wave propagation. For the skywave propagation, we use the ionosphere that is like from 9 kilometers to up to 600 kilometers above the ground. So it is a region, we use that region for the wave propagation. Like let's say in this case, we have there, let's say here's an access point, or here's a transmission station, and the signal will go up and will rebound or will reflect from the ionosphere. So ionosphere has the ability to reflect the signals which are in the range of 3 megahertz to 30 megahertz, right? So if we go above 30 megahertz, the ionosphere will no longer reflect the signals. So it can it can go past through the ionosphere. Now the third one, transmission mode, is a space wave propagation. So the space wave propagation, it works in line of sight. So it has a frequency which is greater than 30 megahertz, and it can cover large distances. Like let's say it can be used for satellite communication, which are up above like 36,000 kilometers above the ground, like geostationary satellites. And the one disadvantage of the space wave propagation is that it can be disturbed by the obstructions. So the communication which uses frequency above 30 megahertz can be disturbed by obstructions. They can be reflected, or they can be refracted, or even they can be observed by some materials. Here you can see that we have a different range of electromagnetic spectrum. So we use these like from 3 kilohertz up to, let's say this is the 3 kilohertz to 30 kilohertz, and this is the 30 megahertz. So we can use for the ground wave propagation, and for the sky wave propagation we can use this frequency, and for the space wave propagation we can use frequency range or frequency band higher than 30 megahertz. Okay. So all these wave propagation take place via electronic device or electrical device that is antenna. That is, we call the antenna or antennae. So what is an antenna? An antenna can be defined as it is a transducer between two guiding waves. Like if we have two devices, as I have mentioned earlier, if you have two devices, one is over here, like one is over here and the other is over here, and we want to transfer the data from one point to another point, so we will use antenna for these. And these antennas are, you can say these antennas are transducers, because antenna, they are capable of converting the energy from one form into another. Like in this case, it can convert energy from electrical signals to electromagnetic waves, which can travel even in the vacuum, because they don't need any physical medium or object to move. So these antennas can be defined as an electrical conductor or system of conductors used either for radiating electromagnetic energy or for collecting electromagnetic energy. So in this case, as you have seen that we have two devices, like one is, let's suppose we have two devices. one is here and the other one is here. So we can use the same antenna to produce signals or to transmit signals or data from one point to another, and we also can use the same antenna to receive the signals and or receive the data from one point to another. So it is capable of producing or generating and receiving the electromagnetic spectrum. So like in this case we have these 2 points, we have this point and we have this point. So antennas can be transceivers too. By transceiver we mean that an electrical device which is capable of producing or generating data and also which is capable of catching or gaining, or which is capable of converting the electromagnetic wave into electrical waves. So to transmit the signals, radio frequency electrical energy is converted into electromagnetic energy and radiated the surrounding. Similarly, to receive the signal, electromagnetic signals collected and are converted into radio frequency electrical energy and fed into the receiver. The device which is capable of producing and receiving the signals is called transceiver. Now we will discuss about antenna, that how an antenna will work or how antenna works. So in this case we will take a dipole antenna, which is theoretically the simplest form of antenna. So it includes two, let's say it includes these two are conductors. These two are conductors. So we have two conductors and a power source over here. When a power source supply power to the conductors on the both side, but make sure that, or keep it, you should keep it in mind that the power source we apply will be alternating current. If it is not alternating current, if the charges stay on the same position, it will not produce any electromagnetic signals. So in this case, when we supply a power to the conductors, on the both ends either we will have a positive charge or a negative charge. So let's say in this case, if we have positive charge over here, like if we have positive charge over here, so we will have a negative charge over here. So the continuous change of these electrical charges will produce electromagnetic signals, and it will propagate through the surrounding. So how it is producing the electromagnetic signal? It is produced by the movement of charges, which are electrical charges. So as we know that the movement of electrical charges are whenever there are two charges. Let's say we have one charge over here, let's say we have one charge over here and the other charge is over here, and it has a positively charged particle and it is a negative charged particle. Let's say we have two charges like this and this one. So it has positive charge and it has negative charge. So these charges will produce an electrical signal. Now when we provide power to the simple dipole antenna, the power is like it is alternating current, so it will move from one point to another. So in this case you can see that when we provide electrical alternating current to the conductors, these two conductors, so the current will, when the current flow in this direction and here, so when the current flow in this direction, it will have positive charges, and here on the opposite side it will have negative charges. So when the current flow in this direction, it will produce it will produce magnetic field. So the movement of positive and negatively charged particles, which already has the electric field, and whenever we move through from one point to another point, it will produce uh, magnetic field, and in return we will have electromagnetic signal. Now we will discuss about the antenna, that how what is an antenna. We already have discussed it and how it works. So in this case we will take the dipole antenna, which is theoretically is the simplest form of antenna. So in dipole antenna we have two conductors and a source, or we have a power source. So in this case when we supply electrical power, or the electrical source supply the power to the dipole antenna, so the current will, at one stage the current will start flow from one point to another. Let's say in this case the current starts flow from this point to this point. So what happens when the charges, all the charges come up to this like this conductor, it will get positively charged and the other conductor will get negatively charged. So what happens then? The electrical, as we know that when the electrical charges move from one place to another place, they already have the electrical field. So when these charges move from one place to another place, they produces magnetic field, and the combination of that magnetic and electric field produces electromagnetic waves. So continuously when the charges move along this path and along this path, let's say this path, the continuous movement of these charged particle will create electromagnetic wave. We have different types of antenna, in which the first type is a directional antenna. So a directional antenna is a radio frequency wireless antenna designed to function more effectively in some directions than in others. The purpose of that directionality is improving transmission and reception of communications and reducing interferences. So we use the directional antenna to improve the transmission and reception on the transmission side and on the reception side. In consumer applications, the most common directional antenna is a dish used with satellite internet and satellite television installations. In the coming slide, presentation slide, we will see the example via graphical pictures. And other types of directional antennas such as Yagi antenna, quad antenna, billboard antenna, and helical antenna. All these antennas are used in a variety of applications for different purposes and for different applications. Let's say, for example, we have a Yagi antenna which is mounted outdoor, and it can work well for a wireless internet connection in remote area, because Yagi antenna drastically improved the range compared with the conventional indoor antenna or other antenna we use inside or indoor our homes. So you can see that in this example we have a ground station which is providing internet service to the consumers. So you can see that here in this case we have, this is the internet service provider which provide internet, but let's say this is a home, or this is an area which is far away from the ISP service provider, and let's say the ISP service provider cannot install wires and other physical objects to provide the internet to the home or to the houses. So it will it there we will have we can use satellites for communication. So for directional antenna, we have satellites over here. Like this is a direct, as you can see that this dish antenna is a directional antenna. So other antennas like semi-directional and omni antennas cannot like they are unable to establish such a link that can transmit the data or transmit the signal from the ground to a satellite. So we use directional antennas. So this directional antenna will provide or transmit the signal to satellite, and then the satellite will provide the signal to the home or houses. Similarly, we have the digital broadcast system TV broadcasting. In this case, it is a very similar case to the internet service provider. So in this case, we have this is the DBS or digital broadcasting service provider. It broadcasts signals or it sends the signals or data via uplink frequency to the satellite, and then the satellite again resend that signals to different areas. Let's say it will send this signal to different areas via downlink frequency, and the area covered by this satellite, let's say it covers this area. This area is called the footprints of the satellites. So whatever device comes in the path or in the footprint of that satellite will be able to receive the signal of the satellite. So when the signal comes down to the house or dish satellite, it will send the dish will send the signal to the receiver, and the receiver will then decode the signal, and it will then convert it into some graphical pictures or videos. Now we have another type of antennas, that is semi-directional. So semi-directional antennas are designed to direct the RF signal or radio frequency signal in a specific direction for point-to-point communication. Semi-directional antennas are used for short to medium distance communication indoors or outdoors. So this in semi-directional antennas, the signal is or the beam width is a little bit wider than the directional antennas. So you can think of semi-directional antenna as like the half of the omni antenna, or when you get signals from a specific let's say isotropic, there is an isotropic object, and you in some ways you are able to get the signals like in one place. So there are three types of semi-directional category. We have Yagi antennas, we have patch antennas, and we have panel antennas. Yagi antennas are sometimes we have the Yagi Uda antennas are typically used for short to medium distance for the point-to-point communications, and it will go like up to 2 miles. Although high-gain Yagi antennas can be used for longer distances. For the patch antennas refers to a particular way of designing the radiating elements inside the antenna. For the panel antennas are common at ultra-high frequency or UHF. You can say the UHF, it is a frequency band, where they are often used for cellular or mobile base stations or wireless networking due to their size and directional properties. We have the panel antennas are in our cellular mobiles that we carry in our pockets. We have a third type of antenna, which is omnidirectional. So by omni it means that it will radiate the signal in each and every direction. Not really in each and every direction, because when you see the omni antenna like this one, you can see that it will produce a donut-like shape. So it will generate the electromagnetic waves, and it will send the electromagnetic waves in the surrounding, but the right down or right below the antenna and right up on the antenna, you will find the signal very weak. So much like it acts like much like a lantern. Like when you have a lantern, or when you are having a candle, it will spread the light in each and every direction. But if you have ever seen, the downside of a candle, it will have a very, or it will have a weak light point over there. So in the same manner, the omni antenna works like a candle or a lantern. So it will spread the signal in each and every direction except for the upper part and the down lower part. As compared to the directional antenna, the directional antenna or the super directional antenna will work like a flashlight, or it will work like a spotlight. The most common examples are the antenna that we use most commonly in our home are they are omni antennas. Like you have seen the antennas on the 2.4 and the 5 gigahertz band routers. They are the omnidirectional antennas. So it has the low gain. Like you have seen the routers in your home that has 2 or 3 or even a single omni antenna. They are mostly like low gain antennas, and it will cover low distance. Like if you go beyond 100 or 150 meters beyond that point, so it will drop the signal. In the given picture, you can see the omnidirectional antenna, how the omnidirectional antenna generates, or how the electromagnetic waves are propagating from omni antenna to the surrounding. The shape of the signals that omni antenna generates is like a donut. Well, thank you so much. Let us know in the comment section if you have any question about the topic, and if you want to know more about the topic. Your suggestions will be appreciated. Thank you.